So we move on now with our afternoon agenda. Still to come today, we have our wonderful session with Tabitha Goldstubb and science fiction writers Ted Chiang and Ken MacLeod talking about future hopes and fears for technology. So that's at 4:30. We'll have a panel before then, which I will be chairing on looking to the future, a session we just started talking about there, in fact. But before then, we have, and it's a real pleasure to have, a keynote from Dr. Sasha Luccioni, who's the research scientist at Hugging Face. Sasha, really great to have you with us. And Sasha will be giving us the third keynote, actually, of our day on the tech industry and climate change, which we know has come up many times today already. And the title is, Do We Have to Slow Down Development to Slow Down Emissions? So a really fascinating topic. And with that, I'll hand over to Dr. Sasha Luccioni. Over to you, and a really pleasure to have you here at TechUK's Digital Ethics Summit. Thank you.
So I hope you enjoyed your experience so far, everyone. So today I'll talk about this dichotomy, what we think is a dichotomy between the tech industry and climate change. But first, let me take a little bit of a step back. So typically people do see it as an either or issue. So either we're destroying the environment or we're saving it, either technology is doing more harm than good. But I see the reality to be more nuanced than that. And I'd like to talk to you today about two sides of the coin. So on one hand, the true emissions of machine learning and artificial intelligence, and on the other hand, all the positive that can come out, all the positive things that could come out of these technologies, and hopefully ways forward that will benefit everyone. So maybe you've seen these headlines. Basically what they did is they compared a very common transformer architecture with 200 million parameters and these common metrics of a human life, a round trip between New York and San Francisco. And the conclusion is that a single AI model emits as much as 5 cars in their lifetimes. But is this true? Is this true across the board? Well, it's actually a lot more complicated than that. But if you had to remember a few things, is that training an AI model, first, the most important thing is the carbon intensity of the energy grid that you're using. And I'll talk about this later. Multiplied by the hardware that you're using. So here I have a single GPU. In practice now, it's going to be tens or even hundreds or even thousands of GPUs. So these very powerful computing servers. And finally, multiplied by time. So how long you can train an AI model. Now, if we look at the first aspect in terms of energy, this is a map of Europe. And essentially, the greener you see a country is, the more renewable the energy is, the more green the energy is. So to give you an example, the United Kingdom is about halfway there, halfway renewable, halfway non-renewable energies. So the carbon intensity of, for example, if you're plugging something into your local socket, will be the one indicated here. In practice, a lot of AI is done on the cloud. So you're not necessarily plugging your AI model into your electricity socket. You could be deploying it on a server across the world. But the point of this being is that while we don't necessarily have control over what kind of electricity we're consuming locally, because it's defined by our country, by our region, et cetera, we do have the chance to choose this when we're deploying on the cloud. So for example, if you're in the UK and you wanted to train your AI model on the greener grid, you could deploy it in Quebec, Canada, where I am currently located. And here the energy is almost 100% renewable. It's hydro. And so with a click of a button, with the deployment of AI model, you can make your emissions go down by a factor of 10. And obviously, sometimes there's privacy concerns, sometimes there's latency concerns, but in practice, most AI training is done on the cloud. And with the single choice, you can make a very big impact on how many emissions you're emitting. The second aspect that I spoke of is time and hardware. And so this is a recent study done about the computing power demanded by deep learning, which is a form of AI, which uses these big neural networks that are kind of very deep with a lot of layers. And you can see that around 2005, when deep learning really picked up, the computing power
that it required started really growing exponentially. So if we can, in the 1980s and 90s, it was kind of growing linearly, and then all of a sudden we have this big boom. What this means is that current methods of deep learning, of AI, require a lot of compute power, so multiple GPUs, hundreds of GPUs, and a lot of training. So we're talking about weeks and months of training. So this can really add up. Multiplied by, for example, a grid that's predominantly coal or non-renewable energy, this can really add up. And this is where the actual 5 cars in their lifetimes figure comes from. This was a very large AI model, a very deep neural network that was trained for several weeks on what was an average US grid, which is predominantly coal. And so this is the 5 cars, but of course, this is not every single AI model. And so this is why we created this tool called Code Carbon in order to debunk this myth that every AI model emits as much as 5 cars. So we created a tool that can run in parallel to any AI model, or actually any code written in Python, and that will give at the end an estimate of how much emissions were emitted by this process, and give some equivalents of miles driven in a car, days of watching TV, et cetera. And the idea with this is not to shame people, but to inform people about the true emissions of our work, of our practice, of our field, and to gather more information and to be able to give more specific figures about the carbon neutrality or not of AI. And honestly, it's not all that bad. So if we flip the coin on the other side, we can see that AI actually has some very positive potential for the climate and for the planet. A couple of years ago, we wrote this big paper called Tackling Climate Change with Machine Learning. I highly recommend you at least skim it if you're interested in this topic. It was written by a lot of very brilliant minds like Yoshua Bengio and Andrew Ng, which are kind of some of the visionaries of the field of AI. And what we tried to do here is we tried to not only identify all the work that's being done or that can be done in AI and climate change, but also to categorize it a little bit, because of course there's so many things that can be done, so many ways in which AI can help. But some of these things can be more high risk, some of them can be more high leverage, some of them can be uncertain or certain. And so what we also did is we identified these kind of subjects and topics. For example, solar geoengineering which is essentially reverse engineering climate change and trying to counter it with either aerosols in the atmosphere or, clouds generated with molecules, et cetera. And so it's essentially ways of countering climate change in an artificial way. Of course, potentially very high leverage, but also high uncertainty because we don't know the impacts of these kinds of geoengineering approaches on our ecosystems. And so in this case, AI can definitely be helping, and it can definitely be a high leverage opportunity, but it's important to take into account the fact that it's a long-term, high-risk endeavor. Whereas other aspects like facilitating behavior change and helping people understand the carbon impacts of their actions, which AI can also help with, is potentially a less risky affair. And so we tried to help people orient themselves within all the different things that they can do with AI in the field of climate change. And to give you some examples, we created this menu. Hopefully you can see the different categories to help people figure out topics that they're interested in. For example, I'm very interested in farms and forests or electricity systems, and to essentially discover within that subtopic, within the specific thing that interests me, what are the different ways in AI and techniques that can be used. So for example, natural language processing, computer vision, et cetera. And so to give you some examples, some concrete examples, let's start with one of my favorites, which is analyzing rooftops in order to predict their solar potential. So this is actually a pretty high impact opportunity, because what you can do with AI is you can scan satellite imagery, detect rooftops of houses or buildings, and you can see how they're oriented with regards to the sun. And based on the area of the rooftop, you can say, well, for example, your specific house in the London area or my specific house in the Montreal area has this solar rooftop potential of X. You can generate X% of your electricity using solar panels. And this is actually really important because depending on where you live, depending on how much sunlight you get, this can be a very big difference, right? Say I really want to install solar panels on my roof, but I don't know whether I'm east or southeast or, what potential that can give me. And so AI can actually do this scalably across the world. It can give every single person, given that there's satellite imagery in their area, it can give them an estimate of how much solar power they can generate, which is a really great way of empowering people to take actions into their own hands. Another, a bit more chemistry-oriented example is that maybe you've noticed that most of batteries are this lithium design that's been around for a while, and they essentially gradually lose their charge, right? The more we use an electric battery, the less charge it holds. And so, for example, with electric cars, with anything that's electric powered that has batteries, sooner or later we'll have to get rid of them, and potentially, it could be a pretty polluting process. So what AI can do is generate new combinations of molecules that have never been used before in battery making, based on essentially the chemical properties of molecules, and propose new candidates. So which can then be synthesized in a lab and can be tested. And that way we can come up with new batteries that, not necessarily due to their chemical properties, but their chemical potential that was identified by AI. And so this is this is a really big opportunity, because essentially if we have new batteries that can hold charges longer, then we can make anything electric powered, right? From cars to trucks to boats. But batteries are really the keystone of electrifying things. So AI has been doing some great progress here. Another aspect is supply chains. So maybe some of you have noticed how fragile our supply chains are. And with the pandemic, we've realized that, there's somebody like a ship that's, for example, blocking a canal, the whole supply chain system grinds to a halt to a certain extent. And so what AI can do is apply a technique called operations research, which essentially sees all these moving parts and tries to optimize the different parts of a system. So it can be, for example, a supply chain, it can be freight destinations around the world. And so, for example, if a ship is stuck somewhere, they can reroute other ships so that there's less wait time, there's less, pollution, there's less essentially bottlenecks in the system. And so this is a way of seeing the whole supply chain system as a graph and trying to optimize the different parts of the graph. And so in practice, this has been used by a lot of big companies, big shipping companies, in order to make sure that their supply chain is always rolling, and that, they're responding in real time. Either there's a hurricane, or, there's some kind of delays. And so they can reroute ships really quickly without having to spend a lot of human hours in order to figure out better opportunities. And then finally, this example that's more, adaptation based. So as the examples I've been talking about have been more on the mitigation side, which is reducing our carbon footprint. But there are certain things that we already need to adapt to, like extreme weather events, like changing climates, right? And so what AI has been already used for quite extensively is analyzing different kinds of satellite and radar data to help essentially anyone from farmers to municipalities adapt to climate change. So, for example, this can be detecting methane leaks using infrared satellite imagery. And methane leaks are not visible to the naked eye. You either have to go there with a special sensor and detect methane leaks, but it's actually a gas that's 30 times more, has a higher greenhouse gas potential than carbon. And so it's really hard to send scientists off to every corner of the world with a little sensor to detect if there's a methane leak. But AI can do this 24/7 by essentially analyzing the heat patterns of the world, and then sending people to the places where they have the highest potential of a leak. Same thing can be with weather patterns, with clouds, with hurricanes. So this remote sensing aspect and potential of AI is a really big help to many aid agencies and governments all over the world in order to help them respond to climate change. And so how do we equate the two? How do we make sure that we are reducing our impacts while maximizing the positive potential of AI? So what I've been advocating for is the fact that innovation is important. I definitely don't think we should stop doing research, that we should stop deploying AI, but we should start framing it within a broader context of social and environmental responsibility. So this has started, it's coming. I know there's ESG, called ESG initiatives in companies, but it's still kind of something that we peg on near the end. It's not something that's integrated from the get-go. It's more like, oh, well, we developed an AI model and now let's think about the social and environmental impacts. But what I think should happen is that carrying out this projection before a model is developed, before even doing the math or doing the computer science aspect of things, to stop and think of, okay, what are the impacts? If this model did exist, how would it impact societies? How would it impact the environment? So do this kind of analysis ahead of time and then make the choice before actually putting in the time of development. Increased transparency. This is kind of the main reason why we decided to make Code Carbon, because it's true that certain studies have been done about the carbon impacts of AI models, but we don't have enough transparency about every single model that gets trained or submitted to an AI conference, presented, deployed, what have you. There's not enough information. And because of this lack of transparency, we can't easily compare costs and benefits, because so for example, I have a friend who does consulting and they have clients who say, okay, can you give me the carbon impact of this model? They don't have the information necessary for that. And so we need increased transparency to be able to really weigh the costs and benefits of deploying AI and making informed decisions. What I've been working on as well with certain industry members is an ISO certification for green AI. So really to have, I don't know if you have this in the UK, but for example, like Energy Stars for AI. So this is an A or B+ AI model. So this can help people make more informed choices in a kind of a simpler way than giving people grams per kilowatt hour of electricity, right? So having this certification will help people, once again, choose between two models or choose modes of employment, or even make simple decisions like, I'm going to train my model in Montreal, Quebec, in order to reduce its carbon impact. Just small choices like that can really make a big difference. And so something that we keep saying, this is part of the Tackling for Climate Change paper, is that AI is not a silver bullet. It's definitely not a goal in itself. It's only a key part, but only a part of a series of solutions to tackle the climate change crisis. And this is how we've been framing it for a couple of years now. And I think it's important to keep this idea in mind, is that, yeah, AI is great. AI is super impressive sometimes, but it's only part of the solution. And it's really important to make the connections with stakeholders, with decision makers, with scientists, with climate scientists, and to decide if AI is the right solution, is the right tool to be using in a given context. And this is kind of the takeaway of my presentation, is that AI is great, but it's important to contextualize, and it's important to be aware of the broader picture. So thank you for your attention.
Sasha, absolutely amazing and fascinating presentation. Thank you so much. Apologies for the audio problems at the beginning, but it was a real pleasure to have you with us today. And thank you for joining us all the way from Quebec. I'm afraid we
Yes.
don't have any time for questions today, but just thank you so much for being with us, and it was a real pleasure.
Enjoy the rest of your summit.
Thank you. Fascinating conversation. I hope you'll agree.